Okay, good evening, my dear students. Good evening, one and all, once again. So, yesterday we have discussed minors and cofactors, right? So, what is meant by minor of an element? What is meant by cofactor of an element? So, all these things we have seen. So, elements may be from the matrix or they may be from the determinant. Whether it's a matrix or determinant, we can find the minor, okay? But minor and cofactor, they're always determinants. They cannot be matrices. But using all those cofactors, those values, we can construct one matrix. So that is called as cofactor matrix. So whether in the given question, whether it is matrix or determinant, first you have to find the cofactors. And the matrix formed by all the cofactors is called as cofactor matrix. I hope it's clear. Audio and video is clear. Okay. So I've written here, so minor of an element is given by deleting. Minor of an element, Aij, is given by deleting ith row and jth column. Say for example, if there is one matrix like this, if there is one matrix or one determinant, so whatever it is, if there is a 2 cross 2 matrix like A11, A12, A21, A22, so this is the matrix, or you can take a determinant also. So you have to find the cofactors of all these. So how to find the cofactor? First you have to find the minor. So delete this row, delete this column. So when you delete this row containing A11 and delete this column containing A11, it is first row and first column. If you delete, so which element is left? A22. So A22 is the minor. And how to find the cofactor? Cofactor means it's nothing but minor with some appropriate sign. Appropriate sign means positional sign. So for A11, if you delete this row and column, we get A22. A22 is the minor. See, you have to delete this row and delete this column. So what is the answer here? A22. So A22 is the minor. And what is the cofactor? Cofactor is plus A22 because the sign is plus. So the minor with appropriate sign is called as cofactor. So if you take one example, one particular example we can take. We can take one particular example. So matrix A is equal to, say for example, 3, -2, 0, 5. This is one matrix. Now tell me, what is the minor of 0? What is the minor of 0? So 0 is here, it is present in second row. So 0 is present in second row. You have to delete the second row. And where is, in which column it is? It is in first column. So 0 is in second row and it is in first column. So you have to delete this row, delete that row and column. So when you delete that second row and first column, so what is the number here? -2. So -2 is the minor. And what will be the cofactor? To find the cofactor, you have to look at the sign. For 0, what is the positional sign here? I have written the sign scheme. For 0, the positional sign is minus. So the cofactor will be this positional sign into minor. So minus of minus, it will be +2. So like this, you can find the minors and cofactors of all the elements. So in 2 cross 2 matrix, we get 4 elements. We get 4 cofactors. And in a 3 cross 3 determinant, in a 3 cross 3 matrix, there will be 9 elements. For all the 9 elements, you have to write the cofactors. Is it clear? Okay, yesterday we have done some problems. Find the minors and cofactors of these elements. We have done. So we'll go to question number 4. Question number 4. Using cofactors of the elements of second row. It's an important question. Using cofactors of the elements of second row, evaluate the determinant. So I have told you 2 properties. What are the 2 properties? Say, suppose the matrix is A11, A12, A13, A21, A22, A23, A31, A32, A33. Suppose this is one matrix. Its cofactor matrix will be, this is matrix A. I'll write cofactor matrix. You can write cofactor matrix of A. So the symbol for this will be, so what will be the cofactor of this A11? You can take capital A11, or in some books, they will also take C11. Cofactor is denoted by symbol capital A or capital C. So I'll take capital A, capital A11, capital A12. So like this, all capital letters we can take. No? Right. So the first property is the sum of products of the elements of a row. The sum of the products of the elements of a row with the corresponding cofactors, means with the same row. If you take first row in matrix A, take first row in cofactor matrix A. If you multiply and add, so what will be the value of that sum? It is equal to determinant of A. If you take first row in the given matrix and first row in the cofactor matrix, means you are multiplying the elements with the corresponding cofactors of the same elements. But if you take first row here and second row in the matrix, the cofactor matrix, okay, the sum means you have to add. What you have to add? Products. Which products? The element and its cofactor. So what is the element? A11. A11 is the element in the given question. What is capital A11? Capital A11 is the cofactor. Cofactor you have to find. How we find? By deleting the row and column. I explained. You have to multiply these two. Means small a11 into capital A11. Similarly, small a12, it's a cofactor. Capital A12. Small a13. What is the cofactor of a13? Capital A13. So this is always equal to determinant of A. But if you take the sum of the products of the elements of one row with cofactors of another row, means if you take first row in matrix A, but second row in cofactor matrix A. So A11 into not capital A11, capital A21, means second row I have taken. Now A12 into A22. First row here, second row here. A13 into A23. So in the given matrix, I have taken first row. In the cofactor matrix, I have taken second row. Means second row means these are the cofactors of second row. So if you multiply and add, what will be the answer? The answer will be 0. So the sum of products of elements with the corresponding cofactors of the same row. So that will be determinant A. The sum of the products of elements of a row with cofactors of another row. So that sum, when you add them, that sum will be equal to 0. So these are the two important properties of cofactors. So it's very important to write the matrix and its cofactor matrix. Cofactor matrix is very important. You have to find all the cofactors, then write all of them in the form of a matrix. So that is called as cofactor matrix. First you have to find minor, then minor with plus and minus, appropriate sign. That's called as cofactor. So if you write all cofactors in one matrix, that's called as cofactor matrix. Nagraj is raising the hand. Let me see what Nagraj is asking. Just wait. So Nagraj, you can ask your doubt. Nagraj. What is the doubt, Nagraj? Okay. Okay. Fine. Okay, no problem. We go to the next question. Question number 4. Question number 4. So this is the next question. You'll understand. One more time explaining in this question, you'll understand. Using the cofactors of elements of second row, you have to evaluate the value of the determinant. So please observe. Those who are having some confusion, please watch this example carefully and understand. So what the question is, cofactors of elements of second row. So I will mark the second row here. So what is the second row here? 2, 0, 1. Correct? And now tell me, what is the positional, the sign scheme for second row? For second row, minus, plus, minus. Because this is always a plus here at the top. At the top, we're having plus. It starts with plus. So next row will be minus. So for second row, leave the first row. For second row, what is the sign scheme? Minus, plus, minus. Because he has asked second row, elements of second row in the question. So first you have to find cofactors of 2, 0, 1. So what is the minor of 2? Minor of 2. I'll calculate here. What is the minor of 2? You can also directly find cofactor. No question. Cofactor direct ಮಾಡಬಹುದು. So to find cofactor directly, I will tell. Better you find minor first. Okay. So what is the minor of 2? Yes. What is the minor of 2? If you delete this row and delete this column, observe. Delete this row 201 and delete column 521. Why to delete 521? Because I'm finding minor of 2. So where is 2? That column and that row. So if I delete this row and column, if I erase, which numbers are left? 3823. 3823. So what is the value of determinant 3823? You know, 3 3s are 9, 2 8s are 16. So 9 minus 16, it will be minus 7. Minus 7 is the minor. So what will be the cofactor? Cofactor means this minus 7 has to be multiplied by positional sign. For this 2, what is the sign here? I have written the sign scheme. It is minus. So minus of minus, it will be plus 7. So I will just highlight this number. 7 is the answer for cofactor. So next element is 0. Question is cofactors of second row. Second row is 201. 2 is over. Now minor of next element 0. Minor of 0. So where is 0? 0 is here. Here means it is in second row. It is in which column? It is in second column. This delete this row and this column. Which column? 302. Why 302? Because 0 is there. I want a minor of 0 means where that 0 is there, that column. And where that 0 is there, that row. You have to delete. If I delete this row and column, I am left with which number? 5813. 5813. Correct? 5813. So what is the value of this determinant? 5813. 5 3s are 15, 8 1s are 8. So 15 minus 8 is 7. First 5 into 3, then 1 into 8. So 15 minus 8 is 7. This is minor. Now after minor, cofactor. Cofactor means this 7 multiplied by either plus or minus. Is it plus or minus? You have to look at the sign scheme. For 0 here, for 0, what is the sign here? For 0, it is plus 201, second row. For the element 0, what is the sign? Plus. So it is plus 7. Plus 7. So here minor and cofactor both are same. Minor is 7. 7 means it is plus 7 only. So cofactor is also plus 7. So 2 is over, 0 is over. So what is the last number in the second row? Last number is 1. So minor of 1. So minor of 1. You have to delete the row and column. So delete this row containing 1. And which column? 1. 1 is in which column? 1 is in the last column. Which is the last column? 813. You have to delete this. Why we have to delete 813? Because we want minor of 1. So 201, 813. If I delete, which numbers I am left with? 5312. So determinant 5312. So what will be the answer? 5 2s are 10, 1 3s are 3. So 10 minus 3 is 7. So minor is 7. If minor is 7, what is the cofactor? Cofactor of 1. What is the cofactor? Cofactor will be, so what is the sign? For 1, the sign is minus here. The sign is minus. So write minus 7. Minus 7. Correct? So cofactor of first number, cofactor of 2 is 7. Cofactor of 0 is plus 7. Cofactor of 1 is minus 7. So now I have to multiply the second row with the cofactors of the second row. So I'll write here. What is the second row? Can you tell me? The second row elements. What are the second row elements? 0, 2, 0, 1. You have to multiply this with, what are the cofactors? What are the cofactors? Cofactor of 2 is how much? We have got here 7, comma. What is the cofactor of 0? Again 7. What is the cofactor of 1? Minus 7. Answers we have got here 7, 7, minus 7. So 7, 7, minus 7. So second row 201, their cofactors are 7, 7, minus 7. You have to multiply and add. How to multiply? 2 into 7. You have to multiply. Yes. Multiply and add. If I multiply and add, so what I get? So 2 into 7, that will be 14. 2 into 7 is 14. Then 0 into 7. 0 into 7 is 0. 1 into minus 7. Minus 7. So what is the answer? Answer is 7. So this is determinant of A. This is one more method of finding the value of determinant A. So usually how you find the value of the determinant A? By taking first row, plus, minus, plus. By taking first row, usually we expand. By taking first row, we expand and find the value of the determinant. But here we have taken second row, the cofactors, and finally, this is very important, we have multiplied the second row multiplied by the corresponding cofactors. 201. This is the second row. And what are the cofactors? 7, 7, minus 7. Multiply them. 2 into 7, 0 into 7. Multiply and add. So what will be the answer? Answer is 7. So in other words, you have expanded the determinant by taking second row. It means. Is it clear? If there is any doubt, you can ask. You can raise your hand if there is a doubt. This very important concept. Finding the minor and cofactors, and using cofactors, how you can find the value of the determinant. If you take first row, take the cofactors of same first row, multiply and add like this. In the end, I have done it by using red ink. Multiply and add, you get the value of the determinant. Okay, fine. Yes, you can write. You can write this thing. If you're not written, be fast. Take some time and write. Okay. So today I will share some notes. I could not post the notes in the WhatsApp group. So today I will give all the notes in the WhatsApp group. Okay. Next question. Find the adjoint of the matrix and also verify that A into adjoint A is equal to adjoint A into A is equal to determinant of A into I. This is the most important question. This is the most important question. Just wait. Tushar, what is your doubt, Tushar? You can speak, Tushar. Tushar Badiger. Tushar Badiger, you can speak. You can ask your doubt. Any doubt is there? Okay, no question. Yes, you have to verify this. Okay, thank you. You have to verify A into adjoint A is equal to adjoint A into A is equal to determinant of A into I. So this is an important property. This is an important property for your CET also. When you multiply the matrix with its adjoint or adjoint into that matrix, your answer will be determinant of A into I. Determinant of A into I. So that we have to prove. First, we have to understand what is adjoint. See, this is also important for CET. Remember, first you have to find cofactor matrix. After finding the cofactor matrix, if you take the transpose of that, we get adjoint A. First, you have to find minors and cofactors. You can leave out minors. Directly, you can find cofactors. It's very easy. Just write plus, minus, whatever is there, and write the minor. So directly, you can write cofactor by taking that plus and minus. So you get cofactor matrix. If you take the transpose, if you convert row into columns, we get adjoint. So adjoint of a matrix is nothing but transpose of the cofactor matrix. You must note. So what he has given? He has given matrix A. Matrix A is equal to, yes, what is the matrix? 1, 2, 3, 4. This is the matrix. I'll write the sign scheme also here. Plus, minus, minus, plus. Always plus is followed by minus. Plus, minus. Then again plus, below that minus. So this is the sign scheme for 2 cross 2 matrix. Correct? Yes. Now I'll write cofactors. Just wait. Okay. I'll write cofactor matrix. Please observe. Cofactor matrix. Cofactor matrix. Yes, I'll write like this. Please observe. Directly, I'm going to write the cofactor matrix. First, see, there is one technique here. First, I'll write sign plus, then I'll put a bracket simply, minus, put a bracket, then after that minus, put a bracket, plus, put a bracket. This is one technique directly. This is skeleton. In biology, you have studied skeleton. Now we'll put some flesh and blood. This is skeleton of the cofactor matrix. So now plus bracket, minus bracket, plus bracket. So write like this. Now after this plus, what I would write inside the bracket? Here I would write the minor, because already I have written plus here. Inside the bracket I would write minor. Next I have written minus, again I would write the minor. So how to write that minor? Delete the row and column. So plus into, yes, for cofactor of 1. 1 is here. Delete this row and delete this column. If I delete this row and column, which number is left here? Yes, what is the number left? 4. So you have to write 4. If you delete this row and delete this column, I get 4. 4 is the minor, plus 4 is the cofactor. Directly you can write the cofactor. You need not write separately. Minor of 1 is this, cofactor of 1 is this. So that we did in the previous question, because it was the first example I wrote separately. But here is an important question, lengthy question. You can write directly all the cofactors. You need not write separate lines, minor, cofactor, minor. So directly you write like this, cofactor matrix, then write sign, plus, minus, minus, plus, write some brackets. So what to write inside the bracket? You have to delete the row and delete the column, we get 4. So plus 4 is the cofactor. So next what? Next minus of, you have to write the minor of 2. Minus of that minor, right? So if you delete this row and delete this column, delete this row and delete this column, what is left? I'm left with 3. 3 is the minor. Minus of 3 is the cofactor. So directly you can write like this. So delete the row containing 2, delete the column containing 2. So we are left with 3. But 3 must be, yes, it should be preceded by minus sign, because the sign scheme, plus, minus, minus, plus. So minus 3 is the cofactor. The next element, minus of, next element means in the matrix 3. So for this 3, if you delete this row and delete this column, what I get? If you delete this row and delete this column, I am left with 2. Correct? And last cofactor of 4. If you delete this row and delete this column, delete the row, delete the column, I'm left with 1. So if you want, you can write neatly like this matrix. Plus 4 means you can write simply 4, then minus 3, minus 2, plus 1 means simply you can write 1. Very easy. Is it clear? Directly you can write cofactor matrix. How to write? First write plus, minus, minus, plus. Write some brackets, then delete the row, delete the column. What is the number left? Write that number. Again, next delete the row and column, write that next number. So like this, you can directly write cofactor matrix. Now, therefore, adjoint. So the symbol for adjoint is ADJ, adjoint of A. So what is the adjoint of A? I said adjoint is by taking the transpose. By taking the transpose, what I get? By taking the transpose. Transpose means row becomes column. What is the first row? First row is 4 minus 3. It becomes first column, 4 minus 3. What is the second row? Minus 2, 1. It becomes minus 2, 1, second column. This is adjoint. Adjoint of the matrix A. Adjoint A, you can write like this. Is it clear? So very simple. If it's a 2 cross 2 matrix, it's very simple. It's dead easy. Just write plus, minus, minus, plus. Delete the row and column. Write that number. Plus of 4, minus of 3. So like this, you can write cofactor matrix. Just convert rows to columns, that is transpose. So transpose of that cofactor matrix will be equal to adjoint of A. So adjoint of A I got. No, in this question, I'm not finding A inverse. The question is not A inverse. Find adjoint A. Then you have to verify this formula, this property. What is the property here? A into adjoint A is equal to adjoint of A into A is equal to determinant of A into I. So I have to multiply A into adjoint A, then adjoint A into A, then at last I should get determinant of A into I. So before that, we should write the value of determinant of A. So what is the value of determinant of A? That you can write. So determinant of A I will write. So what is the determinant of A? You can write here, somewhere here. Determinant of A. I'm sorry. Yes, please write determinant of A. So determinant of A is equal to, okay, wait. Determinant of A. So what is determinant of A? How you multiply? This is determinant 1, 2, 3, 4. That is a given question. So what is the value? 1 into 4, 3 into 2. So 4 minus 6. What is the answer? Minus 2. So determinant of A is minus 2. Okay. Now I'll come to the main question. Question is verify that A into adjoint A. A into adjoint A. Therefore, I'll start here. Therefore, A into adjoint A. A into adjoint A. So what is the given matrix A? The given matrix is matrix 1, 2, 3, 4. And what is the adjoint? Adjoint I got here. Answer 4 minus 2 minus 3, 1. You have to multiply these two matrices. So in the college we have done matrix chapter, matrix multiplication, matrix addition, inverse of a matrix by elementary operations. All these things we have done. And in Narayana class also it has been revised. Revision is over. How to multiply two matrices? Row into column. You are perfect in that. Matrix multiplication, row into column. Yes. If you multiply, what I get? First row into first column in the beginning. First row into first column. First row is 1, 2. First column is 4 minus 3. So 1 into 4, 1 into 4. Then 2 into minus 3. 2 into minus 3 is minus 6. You know this matrix multiplication. So there are two numbers. First number you have to multiply. Second number also you have to multiply. So this is the matrix multiplication. So next, first row into first column is over. Now first row into second column. First row, the same first row into second column. This is second column. How to multiply? First number 1. 1 into minus 2. 1 into minus 2 is minus 2. Then 2 into 1. 2 into 1 is 2. First row 1, 2. First column is minus 2, 1. So first number 1. 1 into minus 2. Second number 2 into 1. First row is over. Now we'll go to the next row. Second row. Second row is 3, 4. Second row into first column. So second row 3, 4. First column means again 4 and minus 3. So 3 into 4. 3 into 4 is 12. 4 into minus 3. 4 into minus 3 is minus 12. Second row, first column. Then same second row into second column. Second row into second column. So 3 into minus 2. 3 into minus 2 is minus 6. 4 into 1 is 4. Yes, what is the answer? Answer is 4 minus 6. Minus 2. This is 0. Then 0. Minus 2. Correct? If I take minus 2 common, what I get? If I take minus 2 common, 1, 0, 0, 1. I've taken minus 2 common in the matrix. Minus 2, if you take common, 1, 0, 1, 0, 0, 1. What is 1, 0, 0, 1? 1, 0, 0, 1 is nothing but, yes, this is identity matrix, that is I. 1, 0, 0, 1 is nothing but I. So, and what is minus 2? Minus 2 I have got here. Minus 2 is determinant of A. I have calculated here. Minus 2. Minus 2 is determinant of A. So it is determinant of A. Minus 2 means determinant of A. And what is 1, 0, 0, 1? This is I. So look at the question. First part I have proved. What is the first part? A into adjoint A is equal to determinant of A into I, that I have proved. What is the second part? Second part is adjoint of A into A. Reverse. A into adjoint A is over now. Adjoint A into A. Again matrix multiplication. Again row into column. So that you can do. Otherwise, let me do that. Just wait. Yes. Adjoint A. A into adjoint A is over. Now adjoint A into A. Wait, I will share. Adjoint A into A. So what is the adjoint A I got? What is the matrix? 4 minus 2 minus 3 1. 4 minus 2 minus 3 1. This is the adjoint. And what is the given matrix? 1 2 3 4. 1 2 3 4. Adjoint A into A. To multiply this. So please multiply this. Yes. A into adjoint A. I got the answer. Minus 2 into I. Now adjoint A into A. Again, you multiply row into column, please. Row into column. How to multiply? First row into first column. Same. Row into column. We know this. We have done so many problems. So first row into first column. What is the first number? 4. And here, what is the first number? 1. 4 into 1 is 4. Second number is minus 2. And here, second number is 3. So minus 2 into 3, minus 6. First row, first column is over. Next, first row, second column. 4 into 2. 4 into 2 is 8. Minus 2 into 4, minus 8. First row is over. Second row is minus 3, 1. Second row into first column. Minus 3 into 1, minus 3. And 1 into 3 is 3. And last, second row into second column. Minus 3 into 2, minus 6. 1 into 4, 4. It is same as last section. A into adjoint A we have done. Now this is adjoint A into A. So here also I get minus 2, 0, 0, minus 2. See, sometimes even if you don't get, you have to look at some steps and you have to write that answer. Okay. Don't write blindly directly, but if something happens, you should keep in mind. So this is my answer, minus 2, 0, 0, minus 2. If I take minus 2 common, 1, 0, 0, 1. Because same answer I should get, determinant of A into I. So whenever the question is like prove that, you can easily bring that answer. So I proved both. A into adjoint A also I proved, and adjoint A into A. And both are equal to determinant of A into I. Is it clear? In the previous slide, I have proved A into adjoint A. This is A into adjoint A. Correct? So A into adjoint A is equal to determinant of A into I got here. How I have found? First I have calculated cofactor matrix. Directly I have written. How I have directly written? Plus, minus, minus, plus I will write. Then in the bracket write numbers. Deleting the row and column, write those numbers. Directly you write cofactor matrix. Don't write minus and all those things. The transpose of cofactor matrix is adjoint of the matrix. That is adjoint A. Then you multiply matrix A into matrix adjoint A. A into adjoint A I get minus 2 into 1, 0, 0, 1. So determinant of A into I. And next, similarly, reverse. Adjoint A first into A. Matrix AB, matrix BA. Usually they are not equal. AB is not equal to BA. We have studied. But here they are equal. A into adjoint A is equal to adjoint A into A. Correct? So adjoint A into A I have calculated. How? Row into column. Again row into column, row into column. First row, first column, first row, second column. And second row, first column, second row, second column. So again I get minus 2, 0, 0, minus 2. Take minus 2 common. We get minus 2 into 1, 0, 0, 1. So 1, 0, 0, 1 is identity matrix, unit matrix. That is I. Minus 2 is the value of determinant of A. So determinant of A into identity matrix or unit matrix. I hope it's very much clear. Okay. If it's clear, I'll go to the next. Okay. Next question. Yes. Find the adjoint of the matrix. Similar question. Not exactly same. Only find the adjoint. Don't verify A into adjoint A. Don't multiply, please. So don't multiply. Only find adjoint. Only find adjoint of the matrix. Okay. This is a 3 cross 3 matrix. We have to be very, very careful. First, I'll write the skeleton of this cofactor matrix. Please observe how I'm going to write. Directly, I will write. Directly, I'll write. I will not write so many steps. Minor of this, cofactor of this, minor of this, cofactor of this. If you do like that, we'll get 18 lines. Minor, one line, cofactor, another line, 2. There are 2 lines. How many elements are there in 3 cross 3 matrix? 9. So 2 into 9, 18. 18 lines you have to write like this. So that's meaningless. So directly I can write. Just put a big matrix. Put a big matrix like this. Just wait. Just wait. Okay. First write sign scheme plus, then write a determinant. Why I'm writing determinant? Because it's a 3 cross 3 matrix. When you delete the row and column, again you'll get a 2 cross 2 determinant. I hope you're getting my point. In the last question, when you delete the row and column, directly you get the answer number. But since it is a 3 cross 3 matrix, when you delete the row and column, you get a 2 cross 2 determinant. Plus, then minus, again determinant. Plus, minus, then plus, determinant. So like this, after plus, minus, determinant, plus, determinant, minus, determinant, then plus, determinant, minus, determinant, plus, determinant. Correct? You have to write like this. This is skeleton. Now, first plus of, so what is the answer here? Which determinant I'll get? Which minor I'll get? The first number is 1. If you delete this row and delete this column, what I get? If you delete this row and column, which numbers I get? Observe in your notebook. If you delete that first row and delete the first column also, what I get? 0, minus 2, 0, 3. 0, minus 2, 0, 3. Correct? Like this. What will be answer? Answer will be 0. Answer you would write in the next step, not in this step. First you would write all these minors and cofactors. Next, after that, minus into determinant of. If you delete the row and column, in your notebook you have to observe. If you delete that row and column, I get 3 minus 2, 1, 3. 3 minus 2, 1, 3. You do it for all the elements similarly. And tomorrow you tell me the answer. Do it for all the elements, delete the row and column, you do it.